Hello everybody, in this video I'm going to teach you how to repair the ClearCom CC-200, CC-110, CC-220, CC-300 and 400 headsets. These headsets are extremely expensive, and usually the microphone goes bad and the microphone blows out. It's a dynamic microphone. This is not a condenser microphone, so keep that in mind. This is a 600 ohms or so coil microphone, coil and magnet, which is a dynamic microphone. So the reason why these microphones on these expensive headsets go out is that people turn on the phantom power. Remember folks, if you have a mixer and you're plugging in a microphone that is dynamic and you turn on the phantom power, which is 48 volts DC, that could potentially blow the coil in your dynamic microphone. So be very careful which unit or which device you plug this into, because they are not equal. You cannot plug in a device with a dynamic microphone to a headset with a condenser microphone, or vice versa, or a device that requires a condenser microphone. You cannot plug in a headset with dynamic microphone unless you have the option to turn off the phantom power, the 48 volt phantom power. So this is how we take it apart and replace the microphone. Okay, first what I'm going to do is I'm going to teach you how to tell if the microphone has blown away or it has burned out. You could measure the resistance of the coil, microphone coil, from these two pins. I made markings so you could see. This is an XLR plug. So if you're looking at the plug, the right two pins go to the microphone, the left two to the headset. So now we are going to do a continuity test or ohms test, and it should be like open circuit. Watch. Okay, do you know why it's 0 ohms? I'm glad this happened, so I tell you, because when you're measuring, it says 0 ohms, 1 ohm, because the switch is in short mode. Let me tell you, when you have the headset microphone up, it shorts out the microphone wires. It basically makes it direct. So you have to put it in 90 degree to turn off the switch. Now you will be able to measure the true continuity in these two pins. And there you go, nothing. And now I'm gonna show you. Just watch this as I straighten this. Watch. See, continuity is like short circuit. Same thing with, I'm gonna do a continuity test. So open circuit right now, completely open circuit, right? Okay. That's probably my hand resistance there that you're reading. It's an open circuit. Watch the continuity. Like that. So now we're going to replace that mic with another microphone. In order to replace the mic, you have to remove this cap. Now, let me zoom in. As you could see, there are a couple of screws here. You would think, anybody would think that, oh, obviously you have to open those two screws. I mean, you have to open this to open this, right? Incorrect. These screws are to separate the mic from this bar. Basically, it slides out. When you open these, this whole thing slides out. We don't need to do that. We don't even need to open those. We don't need to even loosen those. All we need is a prying tool to pop this out. And from here, we barely have some kind of a leverage from which we can pop it out. Now, I'm going to use a dull knife, but you could use a guitar pick. You could use some other prying tool. I don't recommend messing around with knives because this is dull. I have already modified this knife not to cut my hand. I'm going to be using it. So watch as I remove the top. Oops. It's running away from me. It doesn't want to be repaired. Can you imagine? It doesn't want to be repaired. Now I'm going to use because I created a gap there, I'm going to use a screwdriver. There you go. I put a screwdriver and I twist it like this. Put and twist. Now the top cap comes off. Voila. That's all it is. It's just a cap snapped in. Sometimes they put a little bit of glue, as you can see there, like some kind of a silicone glue that put it together. This, I believe, is silicone glue, black thing. So now this whole rubber container is actually the microphone cartridge inside. This is not the microphone. The center alone is the microphone. This is the rubber vibration isolation. So we remove that rubber vibration isolation, and this is our microphone cartridge. The cartridge itself is connected with 2 wires. So we are going to desolder that. This is a shield wire, as you can see. Okay, we desoldered it. And now we take our replacement, the replacement microphone. We plus and minus. Make sure you don't switch the polarity. Okay. Oops. Okay, my magnet, my soldering iron. My soldering iron generates it's magnetic, so it's catching up the mic. I'm gonna put the microphone in this little holder so it doesn't come up. This is a camera holder, by the way. It's nothing more than a camera holder. You have to utilize whatever is handy, you know. So let's do that now. That's the plus, and the white one is the minus. Now the colors may not be the same color on the ones that you will be opening. Oops, that's a cold solder joint. Hold on a second. Okay, that's a good solder joint. Very nicely soldered. Now I'm gonna put this back together. See this shield? This shield will hit this. I don't like that. I don't like that. I'm gonna put a piece of tape in order to kind of isolate that, you know. We don't want that to be hitting. You've got a small round piece of tape. Very small, round. Just to cover the conductors, or I should say the pins of the mic. It doesn't even look round, but who cares? We just want to cover the microphone conductor. We don't want to cover the breathing area of the microphone. That's where the microphone is breathing from. Microphones must have a breathing area in the back for the diaphragm to move. Let me go from there. See this? I put tape here. I put tape on the conductors, but this is this foam kind of thing is breathing area for the microphone diaphragm, because the microphone has a plastic waving, and when it moves back and forth, it should have room for air to move back and forth on both sides. Otherwise it cannot move back and forth very well. Now we will put this I should have put the tape before I put the there, like that. Maybe another piece of tape, because that tape came off. I'm gonna put another piece of tape right here. I don't like the idea of this hitting that. Now I will put this back in place like so. Make sure it's nice and center, and put the cover back. It should just snap. It just snaps in. Cover snapped in. I'm good to go. Now I'm going to test the continuity again. Moment of truth. Let's see if we get the correct continuity. We must get 550 to 600 ohms between these two pins, and that's what we're gonna test. 550 to 600 between those two numbers. More like 575 is what it should read. Okay, 567, that's right. 567, so that's good. Now watch as I move the headset microphone in rest position on top, it will short circuit the mic. 0 ohms. It short circuits the mic because there's a switch inside. Now that's it. That's how you do it. Oh, now I'm gonna leave a link where you can get these cartridges from. It's very hard to find these cartridges. I'm gonna leave a link where you can get those from, and that's a $300-400 headset. This is I believe this is $299 or $300, but the ones that have double muff, it's up to $400, especially the CC-400, CC-300. This is CC-110. Now if you're replacing this microphone on the CC-300 or 400, this is too small, so you have to probably put a rubber silicone around it to make it fit, because this microphone is for this, and for the CC-400, watch how big it is. Let me bring one. See how much bigger it is? Way bigger. This is the CC-300. So the microphone cartridge is way bigger. This will work for it, but it's not the ideal one. However, for that, this is the correct one. So yeah, that's how you do it. I hope this was educational and it saves you a few dollars, because these things are expensive. Buying just a microphone cartridge for like $40-50 is much cheaper than buying a $300-400 headset again. Alright, thank you for watching. Please make sure to like and subscribe.